Thank you, Andy. Can you guys hear me well in the front, background? Cool. Coinminers detection surged by 8,500% in 2017. How many of you here experienced at least one Coinminer-related incident, either malware-based or web browsing-based? Any answer? Yeah, so obviously it's a big problem. My main goal here today is to give you a set of tools and techniques to deal with this emerging threat. My name is Omri Segev Moyal, and I'm co-founder and head of research at Minerva. In 2016, I had my first encounter with Coinminers and been tracking them ever since. The rapid rise of this threat have pushed me to create this presentation to increase awareness and help others fight it. I would like to thank my research team at Minerva and other researchers such as Badpocket and ZeroDot taking a really strong part in this ongoing war. Coinminers are a new surging threat. One of the biggest signs for rapid emergence is multiples named for it. Just to name a few, it's Coinminers, crypto miners, cryptojacking, I heard some cursing in there, and so on. I personally like to use Coinminers when I speak about the overall problem, malicious, benign, and cryptojacking when speaking about web-based, in-browser JavaScript attacks like Coinhive, and crypto mining when speaking about malware-based attacks. So the rapid increase is usually related to Coinhive as well. Coinhive started last year. It's a framework and APIs for developer to a JavaScript to basically copy and paste into their website and start earning profit from mining on users. It's usually considered a malicious act, malicious attack if the user didn't consent to start it. If a user consent, it's more likely like an advertisement, a replacement for advertisement. If it's hidden and run without consent, it's considered a malware and an exploit, or at least that's the way I see it. The trend is also joined by mainstream threat actors like main bot operators, switching from bots and Trojan, banking Trojans to Coinminers, crypto miners. We also see a really clear shift from ransomware starting to use crypto miners as well. Probably because the ransomware is dropping in profit, bad reputations, users don't think they're going to get their files back anymore anyway, user awareness, increase of better security tools. They need to find another way to make profit. And it seems like Coinminer is their new method to do it. Since we can cover all topics in this short presentation, I will try to focus on the key most common similarities of crypto miners. Finding repeatable patterns is always good for defense if we know how to detect them, we know how they look like, we know how to prevent them as well. So looking at similarities, Monero is by far the most common mined coin for malicious actors, dubbed as XMR. It has very strong anonymity features. For example, if you're looking at Bitcoin, comparing to it, Bitcoin address resembles more of your home address, where in Monero, your address is kind of more of the equivalent of a PO box, a virtual PO box. Also, when you look at Bitcoins, everybody can see how much coins you have in your wallet and what transaction you did before and how much you transferred or you got. Where in Monero, it's much more hard to track. The whole algorithms of this coin is much more sophisticated it's much newer as well. In addition, and this is really one of the most critical facts why they use Monero, is that the mining algorithms for Monero is still quite profitable for CPU. And as we all know, bots are mostly relying on CPUs, on computers and servers. And if you look at Bitcoins, even GPU is not much profitable anymore. So this is a key thing to understand. If Coinhive and other web-based services are also using Monero and XMR, anything that can run JavaScript is basically can be a target, a victim of Coinhive, etc. Many attackers, unlike the benign users of Coinhive, will obfuscate the code into many layers. But once you start to peel off those layers, you start seeing that rotten apple, mostly Coinhive, similar services as well. If you want to get really into CoinHive and similar in-browser attacks, there is a really good research by Bedpockets. I think it's the best research to date covering all this topic. The usage of known services makes CoinHive and similar cryptojacking quite easy to detect and prevent, actually. If you're not familiar with it, Coin Blocker List is a really good list of known IPs and domains related to cryptojacking attacks. Zerodot is doing a really good job at maintaining it almost daily. If you can see the tweet, this is from today where he did his last update. Really nice German guy, so if you ever meet him, give him a good kudos to me or buy him a beer. He's really helping the war against crypto miners. So basically, one of the key features of crypto miners, PC-based crypto miners, is XMRig and open source tools that they are rely on. It's basically not that easy to write your own efficient crypto mining, coin mining tool. So the attackers are moving to using XMRig because it's really easy to embed. XMRig is supporting many types of operation systems like Windows, Linux, and Mac. It's really easy to embed XMRig in your own code, and it supports all the major public pools, the joint mining pools. So it makes it really, really effective for attackers to use this tool. If you look on the top left or right from your angle, I've put it a really simple Yara signature. This Yara is just a few lines, but it will detect most unobfuscated coin miners and XMRig, and maybe some other tools that are relying on public pools. In addition, if you want to detect XMRig type of crypto miners, they mostly use a common command line to basically to connect to the mining pools, to decide how many threads they want to run, etc. And this is make them really prone for detection. However, in both cases, more sophisticated attackers will do two things. Like malware, more advanced malware, they will pack their code, so you won't be able to just scan static signatures on it. However, that Yara signature is probably also really effective if you run it against memory. And also, they will, instead of running the XMRig as a standalone, DLL, for example, or PE process, they will embed the XMRig code in their own code and the parameters as well. So it won't be that easily detectable. The reason for XMRig common command line is that it needs to support major mining pools. The reason for both benign and malicious actors, users, to use mining pools is because to mine alone, it's really hard. It's based on luck, and you need a lot of hash power. If anyone here did some mining alone? Have you been profitable? Yeah. So mining pools really give you the benefit of easy calculate how much profit you can make. And for attackers, speaking about really large bots, that's really good and stable income. But the relying on public pools makes them easy to detect on the network as well. Most of the major mining pools, domains, and IPs are known, and you can use lists like a coin blocker list, or I've also shared here in a link a template or a sample to detect with Snort certain network activity and domains related to coin mining. There's also more advanced paid ones, but this one pretty much works, so feel free to use it. For IT and security teams, coin miners are pretty much a pain in the ass, sorry my language. It's killing your CPU. If you got servers, it's going to slow them down. You're going to see a lot of browsers stop operating. They're going to call the security and desktop team to check what it is. But this is also quite of their biggest downfall. Because once, for example, a power user on Windows sees that his machine or her machine start to really slow down, what is the first thing they're going to do? They're probably going to open Task Manager and see what is causing the slowdown, the hiccups. So our little friends in the coin mining, malicious coin mining industry have developed ways to go around it. They will constantly look for this kind of processes and windows like Task Manager, Process Explorer, and once that will be open, the mining loop will go to halt, and they will wait till the Task Manager is closed and then go back again. So you'll find out some users will start delete their Chrome, or oh, what is that causing my computer, and they're gonna miss the coin miner. I think one of the things you can actually try might be run Task Manager all the time, but you can also try and deploy fake processes. Did anyone try to do that before? To trick malware? No. All right, you might should. So getting into a bit of some fun parts. As researchers, I very often get depressed where I try to hunt down threat actors and I usually end up with nothing. But when we do find someone and we're able to track a real persona behind a campaign, it's usually really fun. So when we first started looking at Coinminers, we thought that because of the privacy enhancement of cryptocurrencies, it will be really hard to find those attackers. But we found it completely opposite. And we think that's because crypto mining is really new technology, and like defenders, attackers alike are really prone to do some errors along the way, to run mistake. So just to name a few of the stuff we found is, for example, newbie mining pools. You will need to use your email as authentication for the miners to authenticate your miner. And some of the attackers will use personal emails, and some even use more like disguised emails, but are much easier to track. If you look at any traditional malware, if you ever find an email, that's a really good place to start when you try dox an attacker. And we got the email right away. Some of them actually even by mistake put in the password for the account in there. So you can go and hunt if you want. I didn't tell you that. So we might find some interesting stuff. There's also some really common, more technical mistakes, but we're pretty much not here to help attackers. We help defenders. So if someone really wants to know more about it, please feel free to ask. I might ask some background checks so to make sure you're not an attacker, but we'll be happy to share. So here's a little story. During an investigation to crypto mining, we found a malicious miner we called Water Miner. Water Miner was mostly in Russia. It was Trojanizing GTA mode. And basically, once you start installing the mode or running it, it will be running alongside disguised to an Intel or Oracle. But the attacker left a really nice few breadcrumbs in its source code, which helped us lead to a real Russian entity. The whole story was published on Bleeping Computers. The link is below, so if you're going to go and do a bit of deeper reading into it, please go ahead. So when I first read in this title, the first thing that came in my head is the Jerry Maguire scene of the "Show me the money, show me the money." So I don't know, it keeps ringing in my head. Anyway, doxing crypto mining is fun, but we really wanted to go deeper and understand why this phenomenon is so big. So we really wanted to track down how much money, what is the profit or main incentive for the attackers. And what we thought is, again, really completely opposite than what we expected. Although XMR addresses are really hard to track, mining pool statistics is really public. So once you extract the wallet address and you can automate it, you can do it really easily on a massive scale, you can start communicate with the APIs of those pools to communicate how much money was actually, not money, but how much XMR was actually paid, what's the hash rate, and overall agents. And so it was really interesting to see. For example, you probably noticed I love case studies. So this is a case study about a malware crypto mining campaign called PhotoMiner. PhotoMiner was originally discovered by Gardico and FireEye in 2016. The revelation of it didn't really damage its overall running. And as far as I know, this is the longest and largest running crypto mining campaign. When we did the automation and run around all the wallet addresses and around 500, maybe 600 samples, we found out that the profit that made is going between 8 to 12 million US dollars from 2016. The reason of the big change is that the XMR coin value is quite changing. So sometimes they took the coin when it was $260, sometimes 180, but we're looking at some couple of really good $1 million here. So that really this really for us clearly showed why the big transition is going. There is some money to be made here. It may be not as big as for the early ransomware when people speaking about $80 million and $120 million, etc. But taking the anonymity of XMR and the probability of them actually taking the money to somewhere they can use, this looks really, really big incentive. Now, looking at some of the strength we wanted to pick up from those coin miners, here's another case study. It's called Ghost Miner. Ghost Miner, we started to look on after preventing an attack at a customer, and we started looking at it. We saw a completely PowerShell script that the PowerShell is propagating in the network and was using things like brute force and some exploit to go along. But the interesting bit for us in this attack is that Ghost Miner was vicious against its competitors. It had many set of tools to kill other miners. Apparently the competition is high. It killed processes with blacklist, look for scheduled tasks, look for network activity, and kill those processes as well. So what we did, and the result of it is in the link below as well, is an open source PowerShell script that you can use in your network to eradicate coin miners. And it's really successful. We still haven't found a coin miner that doesn't get hit by that tool. But please use with caution. You don't want your IT guys to call and say, hey, you killed one of my application, or maybe the coin miners that they were running in the background. So use with caution. So a bit what next? Some time? Good. All right. So I like to do predictions because first, I never can really go wrong with them. You know, no one expects 100%. It's all like defense. And also, it's kind of like a gambling thing. So first thing I think we'll start to see is Coinminers, we're going to start use proxies between them and the mining pool. So the network will first be able to be obfuscated. And second, they won't be need to use those domains and get easily detected by the network. Second thing we didn't see yet, but we're quite expecting, is to see the version of bulletproof hosting. We're going to see probably malicious bulletproof pools. They're going to be hiding the data. They're probably going to have more anonymized way to connect to them. This is something we probably expect to see. They're probably going to use things like DGAs and things more advanced malware is using. We're probably going to see also reducing in the CPU usage of the crypto miners. It's probably going to decrease profit in the for long term, but for short term. But in the long term, it's probably going to increase their profit because they're going to get less and less detected. So just a quick recap. We looked at the similarity features on coin miners, for example, XMR and the open source tools they use, the fact they use public pools and things like CoinHive. We looked at methods to detect and prevent them, like coin blocker list. We looked at network detection abilities. We also look how to track them down and dox them. So if you want to have some fun, please go ahead. We looked at how to monitor the magnitude and how much effective are those crypto miners. If you find a crypto miner, you can easily go and check the size and how much profit they actually make. And we also look at some coin miners self-defense or anti-competition tools that we can use in our advantage. So if you have any questions, please go ahead. If you didn't have time to ask, you can ask me offline. I'm pretty easy to find, and my details will be on the next slide. Yeah. Do you mind a bit closer? I can barely hear you. Sorry. Yeah. So DGA is for someone. Yeah, sorry, he asked if we spoke about DGA as a way to bypass network detection. DGA stands for Domain Generation Algorithm, and basically it's a way to not have a static domain. So basically a lot of network detection use signatures on the name of the domain, and DGA is basically a way to go around it to keep changing. For example, I think the first usage was Configure, when it kept changing the domains it was using. Does this answer your question? Cool. Any other question? Don't be shy. All right. So thank you. It was, yeah. So let me repeat the question. Do you ask how do we get best practices for coin miners or? Yes, there is some really good sources. I think what I'll do is I'll post on my Twitter account a follow-up with some of the good sources, because I think it will be too long to name them here. Cool. So thanks, everybody. Any questions, anything, I'll be around here in RSA. If you see me in a pod, let's drink a beer and have some fun. Cheers.